Mesh Deform can work much like the lattice modifier, but instead of using a lattice, it can use another object as its cage. There are some settings which we've covered in other modifiers. For example, you can add this effect to the entire mesh, a single vertex group, or inversely, omit that single vertex group from being affected by hitting the inverse button. The precision will determine how accurate the deformation will be. The higher the number, the more precise the deformation. The dynamic setting comes into play when there are modifiers or even shape keys that are added to the object. Once you've set up everything you need, you hit the bind button, and this activates the modifier using all the above settings, and you're ready to start editing the cage object. It's important to note this modifier is entirely dependent on the order in which it appears in the modifier stack. In general, you will want to have this higher in your modifier stack, as any modifiers placed above it will cause the modifier to unbind when their parameters are changed, and a lot of your work could be wasted. I have here a Susan monkey head and a sphere which will act as the mesh cage. I've set the viewport of this sphere to wireframe only, so that we can better see the effects. The Suzanne object has got a subdivision modifier added to it. I'll add the Mesh Deform modifier, and I'll select our sphere as the target object. And now I'll put both of these objects into a collection, and I'm going to call this collection Stack 1. I'll now duplicate the collection in my outliner and rename this Stack 2. I'll select all the objects inside Stack 2 and move them over so we can do a little bit of spot the difference. Note that automatically the duplicate Suzanne should have the duplicate sphere set as its deform object. In the Stack 2 Suzanne, let's place the subdivision modifier after the Mesh Deform. I'll select the original Suzanne from Stack 1. Now I'll click the bind button, and all the settings become grayed out. We can now select the first sphere, tab into Edit mode, and as we modify this sphere, the Susan monkey head inside it reacts accordingly. I'll select the Stack 1 Susan monkey head. As soon as I adjust any of its parameters, the Mesh Deform modifier becomes unbound, and the Susan monkey head reverts to its original shape. It's not a simple case of just hitting the bind button again. What this is actually telling Blender to do is to now bind this Susan monkey head to the object that's already been edited. It will not take any of the edits that we've already made into account. In comparison, let's select the second Susan monkey head, and I'll do a similar thing. Here, we see that the subdivision modifier is placed below the Mesh Deform. We can tinker with these settings, and the Mesh Deform is still bound. There's a couple of things to note here. One method isn't inherently better than another. There will be times when you want to place a subdivision modifier before a Mesh Deform, because this gives you a more accurate deformation, as the Mesh Deform will take into account all the new topology generated by the subdivision. In our Stack 2 example, the only topology the Mesh Deform modifier is working on is the original low poly mesh. I'm going to add a wave modifier to each of these spheres. They'll rotate around the y-axis 360 degrees over 250 frames. On the Stack 1 Susan monkey head, I'm going to enable dynamic, but I won't enable dynamic on the Stack 2 Susan monkey head. I'll click bind for both, and then play the animation. They appear similar, but let's stop right here on this frame. Here is where you can see how dynamic will give you a more accurate calculation when using an animated mesh to deform your object.